name is Ian Baldwin. I am an engineering technician and new product development at Charter Medical. We are a life sciences company that makes single-use equipment such as blood bags, cryopreservation bags, manifolds, transfer sets, all those good things. Excuse me. This week I had the pleasure of visiting the BioSpherix Biotech Bootcamp, where I gained hands-on experience with traditional cell culture techniques, learned about the ex vivo system, and different methods in evaluating cell health. So today I just want to go through real quick what I learned and some of the concepts that I could apply in my R&D and NPD projects. So I quickly learned that cell culture is not just growing cells. You don't just take them, you throw them in a flask, and you're done. It is a very controlled process. Things like aseptic techniques, proper handling, and environmental conditions are extremely important for the successful growth of these cells. So just on a day-by-day, the first day we learned a lot about the ex vivo system, how modular it is, portable systems inside of it, such as log dilutions, the crack system, temperature controls, O2 controls, and just how it's designed for the cells. It is cytocentric, as Colin said. Day 2, we got to establish the cell cultures. We learned some aseptic techniques, proper handling, maintaining environmental controls in the ex vivo system and the traditional BSC, and we also got a tour of WFirm's test bed. Let's see, day 3, we got to change the media in the adherent cells. We evaluated the cell health. We went over a little bit of confluence. Sounds like a short day, but it was not. Day 4, we got to harvest our cells. We counted them, assessed viability. It was a lot. It was amazing. So just going over a traditional cell culture workflow. This is like the day-to-day. You pull someone off the street, you ask them how they culture cells. This is what they're going to tell you. They use a BSC. The process starts with preparation, creating a sterile workspace, wiping everything down, preparing the necessary media and materials, wiping everything down. Did I mention wiping everything down? During the cell maintenance, the cells are monitored through growth and morphology inside the BSC, as well as routine maintenance such as media changes, all done in here. And the main thing I noticed from this is it is highly dependent on careful technique and consistency. Each time the cells are handled, each time they're taken out of the BSC, each time they're taken out of the incubator, there is an opportunity for environmental variables and ourselves to influence the process of these cells' growths. Now, the ex vivo system does things a little differently. The overall goal is the same, of maintaining healthy cells and generating reliable data. But the difference is the ex vivo system allows more control of the environment while it's being cultured. So instead of moving cells in and out of the incubator or the BSC, it's all done within the system. You can seed it, you can culture it, incubate it. It's all done in a controlled environment where the oxygen, carbon dioxide, temperature, relative humidity, all of that is controlled and monitored. This creates a much more consistent environment for handling. 5 minutes remaining, because you know. Yes. So another thing I learned was different cells require different workflows. I hadn't really heard the difference between adherent and non-adherent cells before this week. I put a couple of differences up there on the screen. I'm not going to go too far in depth. We're not going to hear it a third time. The basics, it grows attached to a cell in adherent cells. Non-adherents grow suspended in the media. Harvesting is a lot easier with non-adherent because there's not that extra step. But media changes is a lot easier with the adherent. But the important takeaway is cell cultures, it's not a single process. It depends heavily on the type of cell being evaluated. So we got another compare and contrast with the traditional workflow in the ex vivo. They have the same end goal. They're both designed to maintain the healthy cells, generate reliable results. The difference is how much control is built into the environments. The traditional cell culture method with a BSC relies heavily on operator maintenance, maintaining sterile techniques, minimizing changes in the work environment. The ex vivo system shifts some of that control from the operator into the workspace to create a more controlled cellular environment. I got some differences up here, as I mentioned, and the thing I like the most is the design philosophy. Collins mentioned it the first thing, and it really stuck with me the whole way. The traditional method with a BSC is designed around the user. It's comfortable, it's cool, but all this is at the expense of the cells. The ex vivo system is cytocentric. It is designed around the cells. The whole time they are in an ideal environment for them, for optimal growth. It just really stuck with me, so I wanted to point that out. So at the end of all this, we got to harvest and do a little bit of assessment on our cells. For the A549 adherent cells, both workflows maintain very high viability, and the ex vivo sample showed a higher recorded live cell number compared to the traditional workflow. Now, the K562 was a little more complicated. The samples experienced a lot of differences in workflow timing and handling. For example, the ex vivo system K562 samples sat out for about 4 to 6 hours in the ex vivo before we did the cell counting and viability. So all things considered, I still consider 62 pretty good for that. However, this is not a failure. This helps reinforces one of the biggest lessons from this training, that the biological systems here require very sensitive variables, and controlling these variables are critical when getting reliable data. So looking at how I could apply this in my work as a new product development technician, a couple of things that immediately came to mind was cell-based product evaluation. So instead of looking at how does this plastic work mechanically compared to this plastic, we can actually focus on how does the cell behave in these systems. Do they grow well? All those good things. We also can evaluate cell viability after cryopreservation with our products, which is one of the big things we were focusing on before we came into this. We can also reduce our external testing dependence, and generate faster feedback during development if we do this all in-house. One of the main benefits I saw was using a control system like the ex vivo. It could reduce a lot of the environmental variables during testing. We have environmental monitors that can be printed off and can put that in our reports. And this would greatly increase the confidence in any observed differences if we're doing like products evaluations.